Hello students, Ncert Solutions, Class 11th, Physics, Chapter number 9, Mechanical Properties of Solids. Question number 7. Four identical hollow cylindrical columns of steel support a big structure of mass 50,000 kg. The inner and outer radii of each column are 30 cm and 60 cm respectively. Assume the load distribution to be uniform. Calculate the compressional strain of each column. The Young's modulus of steel is 2 into 10 to the power 11 Pascal. Here in this question, a big structure of mass 50,000 kg given capital M is equal to 50,000 kg. This big structure of mass 50,000 kg and four identical hollow cylindrical columns support this big structure. Right? Given four identical hollow cylindrical columns the inner radius of each column, that is R1 is equal to 30 centimeter is equal to 0.3 meter, and outer radius is R2 is equal to 60 centimeter that is 0.6 meter, and given the Young's modulus for steel is 2 into 10 to the power 11 Pascal. Now, this total load distribution to be uniform. Load on each column is equal to F is equal to this mg by 4, because there are four columns and total mass 50,000 kg, and therefore this weight is m into g, and this is equal to 50,000 into 9.8 by 4, and on solving this is equal to 122,500 Newton. This is the total load on each column. F is equal to 122,500 Newton. Now area of cross section of each column capital A is equal to hollow cylindrical columns. Therefore, area of cross section is pi this R2 square minus R1 square. Now, on putting the value 3.14 into this is 0.6 square minus 0.3 square, and this A is equal to 3.14 into this is on solving 0.27 is equal to this 0.8478. Pi is equal to this, and this is 0.6 minus 0.3 square. This is 0.6 plus 0.3 into 0.6 minus 0.3. On solving this is 0.27 and multiply this and this is equal to 0.8478. Right? And we know that compressional strain is equal to this stress upon Young's modulus, or this stress is equal to force upon area. Stress is force upon area upon Young's modulus, and this can be written as F upon A into Y. Now on putting values, this is F is equal to 122,500 and area of cross section is this point 0.8478 into Young's modulus is 2 into 10 raised power 11, and on solving this is 1225 upon 1 point, दोनों को मल्टीप्लाई 2 से इसको मल्टीप्लाई किया तो दिस इज 1.6956 into 10 raised power minus 9, and on dividing this by this is equal to this is 7.22 into 10 raised power minus 7, right? तो दिस इज द कंप्रेशनल स्ट्रेन. क्या किया हमने इन दिस क्वेश्चन? This big structure supported by 4 cylindrical columns, and the mass of this big structure is 50,000 kg, and the inner and outer radius are given 30 cm and 60 cm. Convert किया 0.3 meter, this is 0.3 meter and this is 0.6 meter. Now Young's modulus of steel is also given. This is 2 into 10 raised power 11 Pascal. Now load on each column is mg by 4 because the mass is distribution to be uniform. सभी पर equal distribution है mass का. Therefore this mg by 4 is equal to this mg. M is 50,000 and G is 9.8 by 4. On solving this, now area of cross section of each column is pi r square होता है. Outer area minus inner area. So this is 3.14 into 0.6 square minus 0.3 square. On solving this is 3.14 into 0.27 is equal to this is 0.8478. Now we know that the compressional strain is stress upon Young's modulus, and this stress is force upon area upon Young's modulus, and this is F upon Ay. Now on putting the values and solving 7.22 into 10 raised to power minus 7, this is the answer of this problem. आशा करता हूँ कि आपको समझ में आए. थैंक यू.